Okay, so I haven't been making videos in a while, but now let's try and get back into the swing of things. Exam math solutions. I've done a couple of physics videos recently. So let's see. Prove that when the two circles intersect at right angles, then we have this equation. So what's going on here? You've got two circles, and at their intersection, their tangents are at right angles. So the first circle we have is x squared plus y squared plus 2g1x plus 2f1y plus c1 equals 0. So what's that? That center is minus g1 minus f1, a radius of square root. What is it now? I always forget this formula. Let me think about this. It's f1 squared plus g1 squared minus c squared. Isn't that it? Yeah, I'm pretty sure. Well, if I don't get this result here, then I know I've done it wrong. And likewise for the other circle, it would be, it looks like the same equation, just with 2's in it. And radius 2 is square root f2 squared plus g2 squared minus c2 squared. So let's get the slope of the tangent. So that's 1 and 2. If we say like circle 1 and circle 2. The derivative. And do we know the point? We don't know the point, so we'll just say the point is xy. So 2x plus 2y dy dx plus 2g1 plus 2f1 dy dx equals 0. So that's for circle 1. And then likewise, you have 2x plus 2y dy dx plus 2g1. This is an implicit derivative, plus 2f1 dy dx equals 0. But just perhaps to draw a distinction, that dy dx, that's for the first circle. So maybe I should write like c1 here and c1 here, and this is the slope for c2. So this first one here, that has a slope of dy dx c1, and this one has a slope of dy dx c2. So by rearranging those equations, we can get our two slopes. So the slope of the first one, if you prefer, you can call it m1, equals dy dx c1. So that would be, actually I can get rid of all these 2's here, can't I? So it'll be minus x minus g1 over y plus f1. And likewise m2, that would be dy dx c2, and that would be minus x minus g2 over y plus f2. But remember, because they're perpendicular, m1 times m2 should equal minus 1. So that means minus x minus g1 over y plus f1 times minus x minus g2 over y plus f2. That should equal minus 1. So if I multiply that out, well, all the minuses cancel here. So I'll get x squared plus g1x plus g2x plus g1 g2 over y squared plus f1y plus f2y plus f1 f2. That should equal minus 1. I'm getting closer. I'll just need to make a bit more space. Oh, come on, why aren't you erasing? Okay, cross multiplying, and I get x squared plus g1x plus g2x plus g1 g2, and bring that up and left, so it's plus y squared plus f1y plus f2y plus f1 f2 equals 0. So you've got x squared. Now I want to try and make the original equations appear, so I feel like I should not have cancelled by the 2. It might have been better to keep the 2 in it. So if I just multiply across by 2, you get 2x squared plus 2g1x plus 2g2x plus 2g1g2 plus 2y squared plus 2f1y plus 2f2y plus 2f1f2 equals 0. Getting closer. I can feel it. Didn't really need to know the radius. So I'll just make a bit more space here. We can finish it off. So let's make our equation. So we have 2x squared, so we can make an x squared plus a y squared plus a 2g1x plus a 2f1x. Is there an f1x? So I'm going to split this. I'm going to take this for that guy, and the second equation will need a 2g2x. I'm going to take that. 2f1y, I'm going to take that. 2f2y, I'm going to take that. There's no c's, so I'll have to add c to both sides. 2f1y, y plus c, 1 plus x squared plus y squared plus 2g2x plus 2f2y plus c2 plus 2g1g2 plus 2f1f2, and I added c1 and c2 to both sides. But if you look, the first few terms is 0, and the next few terms is 0 as well. So you end up with 0 plus 0 plus 2g1g2 plus 2f1f2 equals c1 plus c2, or in other words, 2g1g2 plus 2f1f2 equals c1 plus c2. So that proves that A and B are points on the plane. Show that the set of points S where AS equals twice AB is a circle. Find the equation of the second circle, center 0, 0, which intersects S orthogonally. Okay, so I can clear this off now. Right, so let's think about this. You've got 2 points, A, and then B is 2, 3. Show that the set of points S where S is a point where AS equals twice AB. So for example, you have some point here like S, and this distance here is twice that distance. And if you maintain that ratio around, you'll form a circle. So feeling like distance is what we need. If we call S XY, B is 2, 3, A is 1, 1. So if we call that distance 1 and distance 2, distance 1 squared over distance 2 squared is 2 to 1, is 2. And that will be x minus 1 squared plus y minus 1 squared over x minus 2 squared plus y minus 3 squared. So if I cross multiply, I get 2x1 minus, or x minus 2 squared plus 2y minus 3 squared minus x minus 1 squared minus y minus 1 squared should equal 0. So that's 2x squared minus 8x plus 8 plus 2y squared minus 12y plus 18 minus x squared plus 2x minus 1 plus y squared plus 2y minus 1 equals 0. So that's x squared plus y squared. Let's keep track of this. X squared and then y squared, and then we have minus 8x plus 2x. So that's, whoops, I want to shrink. Why won't it shrink? Ah, it's stuck. Ah. Okay. Right. Minus 8 plus 2 is minus 6x, and then minus 12 plus 2 is minus 10y, and then we have 18 plus 8 is 26. 26 minus 1 is 25. I think I've gotten everything. So that's x minus 3 squared plus y minus 5 squared minus 9 minus 25 plus 25 equals 0. So that's x minus 3 squared plus y minus 5 squared equals 3 squared. So that'll be the circle at 3, 5 with radius 3. Find the equation of a second circle whose center is 0, 0, which intersects S orthogonally. So this is where we could use the result from the first equation. So that's our first circle. And the second circle passes through 0, 0. So that's x squared plus y squared plus c2 equals 0. And we have to make sure these are at right angles. So that means 2g1, g2 plus 2f1, f2, that's 0. has to equal C1 plus C2. So that's, so from the first part, that means we have 0 plus 0 equals 25 plus C2. So C2 equals minus 25. So the answer then is x squared plus y squared equals 5 squared. So that's the second circle. Now, there was a lot going on in this question. I think I would like to graph things to see how they look. Right, so what would I graph first? Maybe I'll graph that equation I just got. X squared plus y squared minus 6x minus 10y plus 25 equals 0. See how that looks. Stuck. Come on. So I want to check with the 1-2 situation here, the AB. It's not plotting for me today. Ooh, very slowly. Let's pause the video for a second. Okay, now it's running at a better speed. So that's the circle. So where are the points? 1, 1 and 2, 1. So 1, 1 would be like here. So can I mark 1, 1 actually off on the? I'm not sure. Is that possible? 1, 1. I don't think I can mark it off quite like that. So I'll just say x equals 1. I'll just draw a line, won't it? Yeah, okay. I'll say y equals 1. I'll just draw a line. Okay, there's 1, 1. And then what's the other point? 2, 3. Two, 3, 1, 1, and 2, 3. So the distance between 1, 1 and the circle and 2, 3 doesn't quite look right, does it? Plus 25, yeah. Well, let's draw the other circle. X squared plus y squared equals 5 squared. Well, they certainly do they kinda, yeah. I might have to zoom in to judge if they're orthogonal. Well, that definitely looks it. And that does too, just about, perhaps. Okay, and then 1, 1 is here. And 2, 3 is up here. Just not sure about the distance part. Like 6. I know what I can do. Like I can see 6, 5 is on the circle. So I'll calculate the distance between 6, 5 and 1, 1. And then 6, 5 and 2, 3. And let's see what we get. 41, 20. Ooh, it's nearly 2 to 1, but there's a tiny discrepancy, which means there's a teeny weeny mistake somewhere, unfortunately. So let's see if we can catch that mistake. 1, 1, 2, 3. That's right, that's right. That's right, that's right. 2x squared minus 8x plus 8 plus 2y squared minus 12y plus 18 minus x squared plus 2x minus 1 plus y squared plus 2y minus 1. Okay. 2x squared minus x squared is x squared. 2y squared wait, I said plus y squared here. I should have said minus actually. That's one, but I had the correct guy here. My plus y squared. X is now 2x minus 6x, and then minus 12y plus 2y is minus 10y. Yeah. And then 18 and 8, 26, 25, 3, 5. I think this is looking okay. Well, I'm assuming from just looking at the graph that 6, 5 is on the circle, but maybe it is not. Yeah, no, it is. It's a tiny bit off. 1, 1, 2, 3. So close. Tiny bit off. I'm going to pause the video, see if I can find my mistake. Yes, I found my mistake. I only have to pause it for a few seconds. So, this is my mistake. Here, I thought I was being clever by removing the square root and only looking at the squares. The problem is the ratio is not 2, it's 4. So d1 over d2 is 2. But d1 squared over d2 squared is 2 squared, which is 4. So I thought I was being a smart guy by not having to worry about the square root. I wasn't being, well, I was kind of being a smart guy, but it snapped back in my face. Here, that's the mistake. It should have been 4, which really, unfortunately, messes things up quite a bit here. Quite a bit. So much so that I just, I have to clear all of this off because I can't really repair it, sadly. So, you know, it happens. You try to make a shortcut, and you end up just costing yourself more time. So that's on me. Well, shortcuts always contain an element of risk. If they didn't, then they would just be the way. So on this occasion, I neglected to consider the 2 has to be squared as well. And so I'm off by a factor of 2 on one side. And I'm surprised that the answer still worked out nicely. So, okay. So that's 4x minus 2 squared plus 4y minus 3 squared equals x1 minus 2 squared plus y minus 1 squared. Let's try that again. 4x squared minus 16x plus 16 plus 4y squared minus 24y plus 36 equals x squared minus 2x plus 1 plus y squared minus 2y plus 1. In total, that's 3x squared plus 3y squared minus 16 plus 2 is minus 16 plus 2 is minus 14x plus minus 24 plus 2 is minus 22 y, and then we have 36 and 16 and 1 and 1, so 36, 46, well actually the ones can cancel here, so that would be 35 and 15, 35, 40, 50, huh? Plus 50 equals 0. Messy. Divide by 3, x squared plus y squared minus 14 over 3x minus 22 over 3y plus 50 over 3 equals 0. And then just repeating what we did, the other circle would be x squared plus y squared minus 50 over 3 equals 0. Now let's draw those and see how they look. I don't like the fractions. X squared plus y squared minus 14 over 3x minus 22 over 3y plus 50 over 3 equals 0. Let's see how that looks. Okay. And then x squared plus y squared minus 50 over 3 equals 0. Now, pretty right angles, but we have to do our distance check then. So they look like they're at right angles. And for this red circle here, remember we have to check that the distance from 1, 1 to the circle is twice the distance to the point 2, 3. So it looks like 4, can't quite tell. No, 4, 4 isn't on it. So it's not quite as easy to read off a point on this circle. So I wonder, I could get the intersection maybe. Messy. But let's try it. Okay. So that's x. And then let's get the y. That's y. Okay, so let's see. X minus 1 squared plus y minus 1 squared, and then we'll do the same with 2, 3. And we'll divide them and calculate. Oh, here we go. Nice, 4, which is 2 squared. Yeah, so actually if I wanted to be more precise about it, it is square root that over square root that. So, whoops. Oh. Yeah, so that's the distance from 1, 1 to a point on the circle, actually one of the intersection points, and 2, 8, and 2, 3. And if you calculate that, you get exactly 2. So, okay, I think we're finished with this question. That took longer than I planned because of my mistake. These things happen, I suppose. Prove that when those two circles intersect at right angles, we have this equation. Done. Those are points on the plane. Show that that equals twice that. I mean, if that's the case, prove it's a circle. So I've done that correctly now. Find the equation of the second circle centered at 0, 0, which intersects this S we just found orthogonally. So that's S, and that's, we'll call it S, or maybe, yeah. So those circles intersect orthogonally. Yeah, okay, this is done now. Tricky question. You can see that the circle questions were much harder in the past. Well, at least some of them were. I mean, this was a pretty tough one. So anyways, we're done now and we're happy, I hope.